This is Dr. Mohan Lakshmi, Professor and Head Department of Electronics and Communication Engineering from Rohini College of Engineering and Technology, Kanyakumari district. So, in this lecture, we will see another device which is a UJT, which is Unijunction Transistor. So, on completion, you'll be able to say what is UJT, what is the operation, and what is its characteristics. So, UJT, you can see here the symbol is given as well as how it is constructed. It is another solid state 3-terminal device that can be used in gate pulse, timing circuits and trigger generator application to switch and control thyristors and triodes for AC power control operations or applications. So here you can see three terminals which is related as emitter, base 1 and base 2, and here you can see here there is a channel between the base 1 and the base 2 terminal, and here the emitter is a P type and you have here this as an N type, so this forms a PN junction. So this is a equivalent circuit of UJT which have an unidirectional conductivity and negative impedance characteristics, acting more like a variable voltage divider during the breakdown. So this is the construction which you have seen in the previous slide, and this is a simplified equivalent circuit. So the PN junction is replaced with the diode, and we have the resistors B1, RB1 and RB2. So here, as the physical position of the PN junction is closer to the terminal B2 than B1, the resistive value of RB2 will be less than RB1. So these two series resistances produce a voltage divider network between the two base terminals B1 and B2 of the UJT. So here this channel stretches from B2 to B1 when a voltage is applied across the device. The potential at any point along the channel will be in proportion to its position between terminals B2 and B1. So the level of the voltage gradient therefore depends upon the amount of the supply voltage. When used in a circuit, terminal B1 is connected to ground and the emitter serves as an input to the device, as you could see from the equivalent circuit. Suppose a voltage VBB is applied across the UJT between the base terminals B1 and B2, so that B2 is biased positive relative to B1. So both will be positive, but B2 will be more positive. With zero emitter input applied, the voltage developed across RB1, that is, which will be of lower resistance, of the resistive voltage divider. This could be calculated as, for a unijunction transistor, the resistive ratio of RB1 to RBB is called as the intrinsic standoff ratio. So the typical values of eta will range from 0.5 to 0.8 for the most common UJTs. So if a small positive input voltage, that is less voltage developed across the resistance RB1 is now applied to the emitter input terminal, the diode PN junction is reverse bias. Thus it will offer a high impedance and the device will not conduct. Now you say that the UJT is switched off and there will not be any current flow. However, when the emitter input voltage is increased and becomes greater than VRB1, or it is about eta VBB plus 0.7 volt, where 0.7 volt equals a PN junction diode voltage drop. Okay, so this become forward biased and the UJT will start conducting. So the result is that emitter current will flow. So this is the UJT characteristics. You could see here there is it is drawn between the voltage and the current of the emitter terminal. So you could see here there is a negative resistance region, there is a saturation region, there is one particular point which we call it as a valley point, and again we have a cutoff region. So it is shown for different values. So that is example 1, you can solve it. So you need to find out what is the intrinsic standoff ratio for a UJT, which is determined to be 0.6. If the interbase resistance, that is RBB, is given to be 10 kilo ohm, what will be the values of RB1 and RB2? So how do we solve it? So it can be solved as, so of course we know that the interbase resistance is 10 kilo ohm, and please try to solve that one. You can easily solve, okay, where the expressions are given in your previous slide. The most common application of a UJT is it will act as a triggering device for SCRs and triacs. Other applications include it will be a sawtooth generator, simple oscillators, phase control, and timing circuits. The simplest of all the UJT circuits is a relaxation oscillator, which will produce a non-sinusoidal waveforms. So I think this you will be familiar with your in school level educations. So these are the possible assessment question. Define intrinsic standoff ratio. What is UJT? What could be the applications? You could be able to solve to find out the standoff voltage if the intrinsic standoff ratio is known. So what is the VP, that is a peak point voltage, if the forward voltage of a particular PN junction is given. Thank you.